Static electricity refers to the buildup of electric charges on the surface of an object due to an imbalance of electrons. It occurs when two objects come into contact and electrons are transferred between them, resulting in an excess or deficiency of electrons on the surfaces of the objects. This leads to the development of electrostatic charges. The distribution of electrostatic charges in static electricity follows the principle of charge conservation. According to this principle, charge cannot be created or destroyed but can only be transferred from one object to another. When two objects come into contact, electrons can move between them, causing a redistribution of charges. There are two types of charges, positive and negative. Positive charges are associated with a deficiency of electrons, while negative charges are associated with an excess of electrons. When two objects come into contact, electrons can move from one object to the other, resulting in one object becoming positively charged, electron deficient, and the other becoming negatively charged, electron excess. The distribution of electrostatic charges depends on several factors, including the materials involved, their conductivity, and their relative affinity for electrons. Materials that are good conductors, such as metals, allow electrons to move freely, resulting in rapid charge equalization. On the other hand, materials that are poor conductors, known as insulators, impede the movement of electrons, leading to a more persistent separation of charges. For example, if you rub a plastic rod with a piece of fur, the rubbing action causes electrons to transfer from the fur to the rod. As a result, the rod becomes negatively charged, excess of electrons, and the fur becomes positively charged, deficiency of electrons. The charges are distributed on the surfaces of the objects involved. The distribution of electrostatic charges can lead to various phenomena, such as attraction or repulsion between charged objects. Opposite charges attract each other, while like charges repel. This is due to the electrostatic force, which acts between charged particles and is governed by Coulomb's law. It's important to note that static charges can be discharged and neutralized when the charged object comes into contact with a conductor or a path to ground. This allows the excess or deficient electrons to redistribute, returning the objects to a neutral state. In summary, static electricity involves the buildup of electrostatic charges on the surfaces of objects due to the transfer of electrons. The distribution of charges depends on the materials involved and their conductivity. Opposite charges attract, and like charges repel, leading to various observable phenomena.